Assalamualaikum. Here we go. I am Ayaz Ahmad Qureshi and I'm here for your next video of Edexel IAL. In this video, actually, I'm going to discuss about the equipotential surfaces. As you know, that all these equipotential surfaces, they are the surfaces where the potential difference is zero. Yani they all have same potential. So here in this setup, we are going to check that an operators for investigating the equipotential surfaces. For example, if we see that there is a potential between these 2 points, so we must have the same reading. So this is basically the equipotential surfaces concept, right? So in equipotential surfaces, these all here I have mentioned in my slides, that electric potential charge from the place to place it moves, and those locations all have the same potential, and when they all have the same potential, they are connected with the lines. They are called your equipotential lines. Yani simply speaking, very simple to understand, that all those fields, if I trace the position of the charge particle, and that charge particle is traveling from one point to another point, at that time, whatever the path we face, or whatever the path we have, that is your equipotential surfaces, or that is called equipotential. For example, if I see, or if I say that yes, I have a charge particle, usually these equipotential surfaces are in circular parts. Let's say, here we go, sorry for this inconvenience. Let me draw it here, although it is not good that I'm going to draw on the notes. But for example, if I have a charged particle, and that charged particle is moving in different areas of areas around this positive charge, and if I join all these points, this line, or this is called an equipotential. So potential for all these points is same as compared to that of the central charge. So that is why this line, this zone, this purple color line is called your equipotential. So basically, in equipotential surfaces or equipotentials, the electric field strength is equal to zero. Yani, if I say, in my let me add one page for you. Sorry for this inconvenience, because I want to explain something. That is why I would add a page here, and by that it will be sorry. Yeah, this was a new page. Sorry for this inconvenience. And this is, some sort of inconvenience in the technology, and really sorry for this all disturbance, because there is cold in my area. That is why I have to take some protection as well. Okay, so here we go. For example, as I was talking to you, that if we have the graph of voltages and distance, potential difference, and D, as I told you, that E was equal to delta V divided by D. It means that if we see this area, or this graph, in this graph there will be a sort of variation, and that variation will be actually noticed in this way. For example, if I have a graph line like this, and that graph is having this way, this behavior, and so on. So here in this zone, here the potential variation is equal to zero. I mean that gradient is equal to zero. When the gradient is equal to zero, it means that here the potential or that electric field strength is zero, right? Yani, when I define electric field, definitely there is no force acting on this. In the same way here, the potential varies, and that is not equal to zero. That is why the gradient is not equal to zero. When gradient is not equal to zero, so definitely your electric field strength is not equal to zero. So that is how you must consider one point what I refer here, that gradient of V and D is your electric field strength. So that is why sometimes we have some sort of graph in my spherical in the charge spheres. I will discuss about that in detail, but here I believe that it is clear to you, so I'm just moving on to my next page. So this is what the major concept of equipotential surfaces. And in equipotential surfaces, here in the last line, very important line, that the field are these lines, as the field defines the region with the charge potential, with the changes in potential. However, close the equipotential, it indicates that the strength of electric field. This shows that how rapidly the electric field is changing. So if I say that the charge over there is changing rapidly, the field strength is changing, so that tells me about the equipotential surfaces. So this is a short topic, small topic, that is why I will not go in depth of that topic that much, because I will discuss some other points ahead in my next video. So here we go. The field lines can never cross each other on equipotentials, and equipotentials can never cross each other in equipotential lines either. So these are some important points you have to keep with you while you are discussing this topic. Hope it is clear to you. I'm just joining you in my next video.